Module 3.3 will look at the impacts of climate change on transportation infrastructure in Suriname. What does transportation infrastructure look like in Suriname? Roads in Suriname are made of asphalt, paved, sand-shelled, and laterite across the country. 78% of roads in Paramaribo are asphalt or paved, whereas most of the hinterland has an underdeveloped road system and they rely on air and water transportation. In Marawene, Para, Brokopondo, and Sipaliwini, laterite roads of a total of 473 kilometers serve as a transportation network for timber, granite, and other natural resources, as well as to connect various villages situated along primary, secondary, and tertiary roads and rivers. All regions and the capital Paramaribo are connected via the primary road system. Often, primary roads end at rivers where transportation continues by water. In terms of air transportation, there are 2 international airports in Suriname, as well as local and small airports spread all over the country, especially in the interior. These airstrips provide transportation to mostly remote indigenous and maroon villages for the purpose of communication, education, and health services, as well as to supply goods such as food, medicine, and fuel. These airstrips also provide services for the tourism industry. Finally, Suriname has 17 certified harbors, most of which are in Paramaribo and Wanica. Which climate hazards are most concerning for transportation infrastructure? Similar to energy infrastructure, transportation infrastructure may be vulnerable to increases in precipitation, high winds, and sea level rise. Transportation infrastructure is also vulnerable to climate hazards such as floods, storms, and high winds, which can cause damage. We will now explore some of the ways climate impacts would affect transportation infrastructure in Suriname through various impact chains or pathways. Similar to the energy infrastructure video, I encourage you to pause the video here and follow some of the pathways. You can begin by looking at the climate impacts which are in blue, which lead to intermediate impacts in gray, and the downstream or final impacts in red. The yellow boxes are showing who or what may be more exposed to the risk, and the green boxes are showing factors that might increase vulnerability. So I encourage you to pause the video here to look at some of these pathways. Now that you've hopefully looked at some of these pathways, I will highlight a few that are key for transportation infrastructure. There are 2 main ways that transportation infrastructure may be impacted by climate change, either through more loss and damage or an inability to use or navigate the infrastructure. Let's explore these further. When we are talking about loss or damage to transportation infrastructure, we are looking at climate variables and hazards, including more precipitation, higher winds, and sea level rise. These can drive other climate hazards such as flooding, erosion, storms, and fires, which can also cause loss or damage to transportation infrastructure. On the coast of Suriname, flooding, erosion, extreme winds, and waves can lead to infrastructure failure or damage, as well as can cause road obstructions if trees, power lines, or other debris is blown onto the transportation routes. When we are talking about an inability to use or navigate transportation infrastructure, we are looking at climate hazards such as more precipitation, more floods, and coastal erosion, which can affect the navigability of rivers, docks, and even roads. An impact to roads is a concern for the interior of Suriname, where heavier precipitation events can leave roads untransitable, so people can't drive on them or use them. What are some of the downstream impacts or consequences of the pathways we just explored as it relates to transportation infrastructure? Any sort of loss or damage to infrastructure and assets may lead to financial losses. Additionally, it can lead to a health risk, even resulting in loss of life. For example, if someone is trying to use a transportation route when a climate event happens. An inability to navigate around the docks and through rivers can lead to financial losses and economic impacts for transportation enterprises, businesses, and individuals who rely on marine and river transport for economic productivity. Additionally, populations dependent on fuels brought by boat to their communities will suffer from reduced or more costly fuel supply due to enhanced challenges when traveling by rivers. Who or what would be more exposed to these impacts in Suriname? So exposure would be specifically for people and infrastructure in areas that are exposed to coastal impacts, flooding, high winds, and storms. And finally, what can increase vulnerability to these impacts? So one factor would be less protective infrastructure. So having a lack of barriers or protective measures in place for transportation routes to protect them from climate hazards, as well as under-maintained infrastructure. So infrastructure that hasn't had frequent maintenance. Let's explore a case study. Meet Lando. He lives in Sipalawini. The rainy season in the interior has been wetter than normal, with heavy precipitation events and riverine flooding. This has damaged road and marine transportation networks in the area. Many of the roads and rivers are also difficult to navigate due to higher water levels and will require maintenance once the water levels have decreased. This has impacted Lando's community as they require riverine transportation to receive essential goods, including food and fuel for their diesel generators. Lando and his family ration their remaining diesel supply and hope that diesel resupply comes soon as they risk energy insecurity. This case study is a good example of how impacts to one type of infrastructure, i.e. transportation, can be connected to other types of infrastructure, i.e. energy. So an impact to road and river is impacting Lando's ability to access safe and reliable energy.